Before others join, or within 2-3 minutes, I will give a brief introduction of myself, because I don't mind latecomers miss that. Recording is already on, so please put your video off. I'm Narayana Damble. I'm basically a mechanical engineer. I worked from 1981 to 1992 as an employee in different types of engineering. From 1992, I have been a freelancer, and I am a happy freelancer, I would say, rather. I'm still doing some little freelancing, but moreover, I am following more of my hobbies, like writing on Quora.com on different topics, engineering, science, and within that, astronomy is my favorite topic. I have written a lot of answers on Quora and content on Quora Marathi as well as Quora English on astronomy. That's it. Meaning, you can have a look at my profiles, and now I'll wait for another 1 minute, maybe till 9:35, and start the presentation. There'll be a brief presentation followed by actual working in QGIS. So anyone wants to take any notes or something, that is not necessary. This session is being recorded. It will be available on YouTube either today night or tomorrow. If you have any doubts, you can unmute yourself and you can ask at any time, but don't make it too much in the so that too much interruption is not there. What I am planning is I'll have 2 sessions of 40 minutes each. 40 minutes because the free Zoom meeting allows only 40 minutes at a time. After the first session of 40 minutes, there'll be a gap of about 5 minutes, which is required for saving the recorded video. Immediately, I'll start the second session. So there'll be 2 sessions of 40 minutes, and whoever is interested in asking questions or have any doubts can ask in between. But we will have a proper question answer session, which will be the third session. Only persons who are interested to ask doubts can attend. Others need not attend, because I'm not going to cover any new topic in the third session. If nobody attends the third session, I'll close it after about 5 minutes. Probably you have understood that. I'll repeat it during the session. And only if you have any doubts, you note down so that you can ask it in the doubt session. And including the doubt session, the YouTube recording will be available on YouTube. So that's how we will go. Now, the basic question, I'll change the view a little now. Okay. So now the basic question in the mind of most of the people would be like, can I make maps? How can I make maps? How complicated it is? GIS is very advanced software. It is complex. So firstly, I'll introduce that aspect to you. I'll clear your doubts on that. Then we will go with some methods and some basic things about GIS. And then we'll go to the actual practical, meaning where we are going to actually start. We are going to actually start the actual presentation. So I'll start with the presentation directly, and most of the things I'll cover through PowerPoint presentation. Okay, there it starts. This session is what I have written on the right side is this session is going to be 2 Zoom sessions every Sunday from 9:30 a.m. India time. That is for your information. And I have already introduced myself. Now, this is just an initial welcome screen where I made a simple small screen video. This is not QGIS. This is actually Google Earth. So Google Earth is also usable software for GIS and creating some maps, but the purpose is different. So this screenshot was taken from, video was taken from QGIS, where you can see how a map is being traced. So why I put it here is that is how you actually make maps from scratch. You can. Not many people would make maps from scratch, but if you start making maps, that need will always arise at some point or the other. Now the next thing what I'm going to discuss is the main doubt that people may have is, how can I make maps? Am I permitted to make maps? Is it illegal? Maps are already there. Maps already exist. So why should I make maps? So basic answer to that is, you can always make maps using software for any purpose and share it privately, or for your school submission, or for any purpose. Especially students will find this workshop very useful, because for students in geography, in schools, you are always asked to make maps rather than getting a traced outline paper and then just filling colors. You can simultaneously make maps using your computer and also learn the software. So it will be very useful. So I hope more students join my workshop in the next sessions after I circulate this video. I hope that. So anyone can make maps, circulate them privately. As far as possible, you should try not to make mistakes, or not to purposely make mistakes. There are people who purposely also do some things these days on social media. You have to take permissions and you have to follow rules only if you are publishing the maps publicly. Meaning, if you want to print a map and publish it and sell it, there are rules. Other than that, you are free to privately make maps and as a hobby or as any purpose. So that issue is solved, and you can make it. It's not very difficult. Now, the next part is, what is the process? Once I said that you can make maps, do I make it from scratch, or I use it from already available data? At the end of today's session, if someone asks you, whoever attended, how did he make maps? Though you might say that, no, he didn't make any maps. He just got some maps from the internet and copy pasted them. It can be looked at like that also. But you don't do that. Meaning, I'm not going to do that. What I'm going to do is, I'm going to get geodata from internet or already available. What is geodata? Geodata is whatever I've shown here, one, two, or three boxes and circles. I purposely made them just black and white. It means that the geodata is just the data and numbers. It does not have appearance. It's not appearance. It cannot be directly looked like a map. It's not an image or a photo. So the geodata has to be put into a GIS software. There are many GIS software. I'm going to use QGIS, which is a free software, open source software, which is free to anyone. So you put that geodata, more than one, always you can put more than one, as layers in GIS software, and from that you create a map. In the GIS software, you do a lot of work to make that map appear the way you want. So this is the basic process. Now, what do you do in that? There are basically two parts. One is put the geodata from different sources in different layers. Then you decide its appearance of the whole map and appearance of individual layer. Appearance of the whole map and individual layer, what is it different? So you'll come to know when we see the actual work. So that is what we do, and then we create a map. Then it can be output as a PDF file. You can take a screenshot, output it as an image or whatever. Now, what is necessary to do all this? See, basic computer literacy is definitely necessary, which I am not teaching. Now, next to that is, I'm going to tell you a little about computer graphics right now, which is necessary for understanding GIS. Computer graphics is in itself a separate, completely different subject, which I'm not going to teach. Okay, that computer graphics was a previous slide. Wait a moment, next slide, sorry. So wait a moment. I'll cover this first. Now, some people may have apprehensions that GIS is a very big software, very specialized people work on it, and it's a highly paid software, very costly software, and highly salary, meaning you also have specialized people getting very high salaries. So it must be very complex to learn, and the learning curve must be, why should I go in that direction? No. Here I am doing a specific and purposeful comparison of learning any other software, mostly graphics or even programming software versus GIS software. This is very, very important, and I'm going to detail about it during next sessions. Now, what happens is most of the software that anyone learns have a minimum basic learning that is required before you can do something fruitful. Meaning, till you learn something minimum basic, you cannot do anything useful or fruitful. Hello World is a very famous in programming languages, where you can immediately get with some few lines of code, you can immediately get the program to type Hello World. It's not practically useful. It's very useful in the sense that once you can get that Hello World in your screen, you know that everything has been installed correctly, and you can now run any code and get the output. So in that sense, it's useful, but it's not practically useful. But anybody asking anything? Okay. So in that sense, GIS is much simpler, meaning the minimum basic learning for GIS is very thin, and which probably most of it I'm going to cover in the forthcoming session within these 5 weeks. You will learn almost everything that minimum basic thing is required for GIS. And as compared to other software, here I have shown is application specific learning. So every software has a minimum basic, and then application specific. There are many different types of applications. So you need to learn many separate things for specific to that application, maybe including domain knowledge. Now, GIS has very huge amount of applications, right? From the common application that we all know, that is Google Maps, Uber, everything is GIS. It's using GIS. So all these applications are very specific, and for them you need to learn a lot, not using them, for developing those applications. But among them, cartography or making maps is the simplest application, where your learning requirement is much lesser. So what you can learn very easily is the minimum basic learning and cartography using GIS. And all these things are specific to application. You do not need them. There are very many applications like water supply, hydrology, rivers, flooding. QGIS can be used, or GIS can be used for many different purposes. So what I repeat is, to make just maps with using GIS software, any GIS software, is not very difficult to learn, not at all. So anyone can practically learn it, whoever has basic computer literacy. Now, the next thing that I'm going to cover is a little about graphics. Everyone knows and has used photos these days with your mobile phone. So in graphics, there are basically two types. Raster is what we have all the photos. So I'm showing a photo of an apple here called as raster. And vector graphics is a different type of graphics, which is not like photo. It is unlike photo. It is more like illustration. So where you can draw lines, draw polygons, draw circles, draw triangles, draw curves. And most important is here, what I've shown purposely is this vector is this rectangle is a vector graphic, which has a separate outline, a separate fill, and there's a text inside. So a vector graphics can have objects, or I'm going to demonstrate that also in the software, can have objects which can have something like a fill, outline, and then some textures of many things are possible. A subset of vector graphics is CAD. It's a big field in itself. CAD is basically vector graphics for more precision. And in GIS, we put all those three things together. We can have everything together in GIS. We can have raster graphics, we can have CAD, meaning GIS itself is a part of CAD, but not exactly. And you can also have vector graphics or vector inside. My cat wants to attend the meeting. नाही इथं नाही यायचं. आशा त्याला नाही ग जरा. हा In QGIS, you can have all the three aspects put together. All the three aspects put together. Now, I will show you within a software, the raster and vector graphics. This is a software which you need not know this software. This is called as Krita. Now, within this software, you can have raster graphics as well as vector graphics together. That's why I've chosen this software to demonstrate this. Now, this is a photo which I have taken. And if you zoom in on this photo, you see after some time you start seeing pixels. Pixels meaning you start seeing dots. See here, everything is made up of dots which are differently colored. So raster graphics is basically you create images or photos, you create or capture. Capture would be the best word. You capture photos from your phone, they all end up as raster graphics. So when I zoom in, you can see that it is made up of dots. Now, vector graphics, instead of dots, it's made up of lines. Now, I had made a separate layer of vector graphics here, already made it. Now I put it on. I can put it off. Now it is on. So what is here is this apple. On the apple, I have made a circle and filled it. I can select this entire thing as an object. See, it's called as an object, which is not possible with pixel graphics, and then change its color or do anything with it. So the outline is blue. I'm changing the outline to yellow now. Now the fill, whatever I have applied to that is transparent. I can make it opaque. So now I made it opaque so you can't see the apple behind it. So the basic logic, it's simple. You can have lines, curves, polygons, circles, anything. You can have an outline to them and have a fill to them. This is very important to understand in GIS because that's exactly we are going to use in GIS software also, in what is called as the vector layers. Now this lines or everything is vector graphics. Now what you can also do is I can select these leaves and I can send them behind, send to back. So once I send to back, see now the leaves are behind the apple shape, whatever I have. So if I make it completely opaque, I can't see the leaves. I can bring these leaves again in front, bring to front, and they move. I can move them separately. I can move this outline separately. So this is basically vector graphics. You need to know only that much, that vector graphics is different. Raster graphics or photos are different. Now, here you have to remember one very important thing, and that is what you see on the screen. What you see on your screen or mobile is always raster. The screen is raster. But then how come it is vector graphics, you will say? The vector or raster graphics difference is only in terms of how it is stored and manipulated inside your device, how it is stored in your computer. Now, I can zoom this. This software has got limitation of up to this, but I can zoom this endlessly and it will still be very clear. So that is the basic objective of vector graphics. Laptop Asha. Sorry. So this he is a common participant in most of my meetings. He also sometimes runs. He likes it anyway. So I have shown you what is raster and vector. Now we'll close this software and go back to my presentation. Go back to my presentation. That echoes because my wife is also hearing it. So I'm back to my presentation, and now I'm showing you an image of the QGIS screen. The QGIS screen would normally look like this. I'm presently giving you a dry run, meaning I will start the actual QGIS probably at the end of the sessions or next 40-minute session. I'll show you what happens so that you get slightly wet your feet kind of. So this is QGIS screen, looks something like this. I'm just put the word QGIS here. So there, when you do create maps, there are basically two areas. One is the work area, wherein you work. Wherein you do your work, which is actually what is called as layers or browser, mostly layers. So you do most of your work in this area, meaning do manipulation here. You add different geodata or manipulate them or do some things in these layers. And whatever manipulation you have done, the map will be displayed here. So these are two areas, and these are all the tools here. Most of the tools. The most important tools you will see here. This is the tool which is the most important for everyone. This shows you the entire map. It zooms into the entire map. And there are more things which I'll tell you as we go ahead. Now, what I have done for this today's demonstration presentation is I have collected some geodata. Now, these are the layers that I have collected. So you can see some of them. I have stored them in a particular folder in my computer, and you will be seeing them from there. There's some sound is coming from behind. Okay. So these are all the layers that I'm going to use. Now, where did I get the layers from? I forgot to put it in the presentation. So you get the geodata or the different layers, geodata layers, free from the internet, and there are hundreds of sources. And the first and most important source is what is called as naturalearthdata.com. From naturalearthdata.com, you can get different sources of data. And here I have chosen 3 from there. So whatever it shows any natural earth in the beginning are the sources which I have got from Natural Earth. World rivers I have got from somewhere else. Goa is, I'm going to show you some Goa villages. I've got them from somewhere else. And state boundary is something of India, which I got from Survey of India. So there are different websites which share many layers of geodata. Most of them are free. And the most available geodata or free geodata is about United States, because they have that free culture. India, there are some layers available, but very few. You can get more data of India from international websites. There are universities which share India village level data free in US, but it's not easily available within India. Meaning you can get it from India, but Indian government websites is not very easily available. Okay, so these is the data that I'm going to use, and this is the map that we are going to create. It need not look exactly like this. Now, what all I have here is I have latitude longitude grid, which is called previous screen. Maybe I'll go to the previous screen. Something has happened. When the I cannot go to the previous screen because something happened when that cat jumped. Anyway, so this is where I am showing different countries and India is colored. So these are the different layers that I'm going to use, and there are rivers that I'm going to use. Now, the same thing can be seen like this with just a flick of one option. The same map, the previous map that I showed, can be seen as like this on a sphere. Now, this is a view how it would be seen from space with center of India as the center, which I have had manipulated using some this thing, which I'm also going to use, meaning that center of India view is not readily available in software. Now, these are the folders in which I'm keeping my data. So all the data will be here. And I'm going to drag and drop it from there. Now, this meeting will last for 10 more minutes. After that, it will end. After about 5 minutes, I'm going to restart the meeting and then we're going to go into the presentation. Now, the next what we are going to learn now within this 10 minutes is some terminology about GIS. To explain that, I have taken a screen capture of the map that I'm making and shown it here. Now, one important fact in GIS is there's some limited terminology which is very important. Now, when I use different geodata and share it, this light is disturbing. When I use different geodata and put it in GIS software, it is called as a feature layer, especially the vector features, or they are called as features, meaning you have a layer which consists of more than one features. Now, each individual feature is called as a feature. Now, there are primarily the features can be of three types: point, polygon, or path. Now, anyone who has used Google Earth to trace maps would already know this, because in Google Earth also you can trace maps and save them as KML file. And these three types of features are available. Point, where they call it something else, meaning they call it as waypoint or marker or something. And then there's a polygon, then there's a path feature. So these cities points that are shown here as point features. The states of India are polygon features, and the rivers are a path feature. So river is like a path, meaning open line, open curve, which is called as a path in GIS terminology. Now, so these three types of features exist in primarily. There are many more things available. So you should know that what is a feature is a single feature, meaning each state is a single feature. Then each river, part of a river is a single, each city is a single feature here. Now, the next thing that is in GIS is a feature can have attributes. Very, very important, because that's how GIS becomes intelligent, or you can manipulate GIS. So every feature can have an attribute. Attributes can be a long list of attributes with many properties. Now, in this case, if I see, I've chosen one point feature in the map. I have selected this Hyderabad city as a point feature. I've selected that, and then I'm seeing its attributes here. So what are these attributes? There are many, but one among them, what he's here, here is name. You see it two, three times. Name is Hyderabad. Name ASCII is Hyderabad, because internally some of the names could be in other characters. So they put it in ASCII as separate. Then mega name. Mega name meaning it's a part of a mega city, or what they call as urban conglomerate, UB, urban conglomerate, and there are some other names for it. So Hyderabad is a conglomerate, so it's a mega city. So mega city name is there, and then there are several data. So all this data is called as, each of them is called an attribute, and so features have attributes attached to them, and you can use attributes to manipulate maps, color them differently, and all that. So the next terminology that we will learn in detail in subsequent on subsequent Sundays, but I'm going to use them, meaning I'm going to use those words, is these are the 4 or 5 most important words in GIS. The first one is, I've said, is datum, then projection, then what is called as a georeferencing, then geoprocessing, and symbology. Basic 5. Now, the datum and projection are most of the times taken together, and many people confuse between datum and projection. We are going to discuss about it. Okay, it's telling me because of that, I think some conch sound, it is telling me playing music. Okay. Datum decides what is your latitude and longitude, meaning I'm sitting at this place. What is my precise latitude and longitude is decided by datum. and datums have changed over the years. One very interesting fact, which I'm going to show you to demonstrate in later session, but I have to tell you today is the datum of meaning, sorry, the longitude of Greenwich meridian, which is precisely the Greenwich observatory in UK, currently is not precisely zero longitude. It is shifted by about 100 meters because we have got a better datum after that laboratory observatory was set up. I'm going to demonstrate that in next Sunday. So next is projection. The projection is, okay, I have not, I don't have my globe here. I forgot to take it, but yeah, I have a blank globe. Projection is required. Why? Because this is a globe which is the actual Earth. Now, this was my globe which I had made for my astronomy Zoom classes. So it has got something which ignore it. So you have the Earth globe is actually on a sphere. Now, if we want to make a flat map of it, we have to do some manipulation, which is called as a projection. You cannot flatten a globe directly. And during projection, there is always a distortion. So we have learned the what this term called as projection. I'm going to use it again. The next is georeferencing. So if you have a map or a geodata, it has to be referenced properly so that it overlays correctly. Now, when we drag and drop some different layers, they're going to automatically fall in their place because they are georeferenced. Georeference means precisely placing your data at the correct place on the map. Now, georeferencing is something that is already done in the layers or geodata that you get. But if you create your own drawing, suppose if you create a map of your plot, a small plot, and you want to, it's available in CAD, you want to put it in GIS, then you have to georeference it. Meaning georeference is a process which is already done on most of the readily available maps. But if you create something, you will have to do it yourself. Or if you create it in GIS itself, it may not be necessary. The next term is symbology. Symbology is the most important work that you're going to yourself do when you create maps. That is what decides the appearance of the maps, how the map looks, what colors are there. All that is covered in symbology. So this presentation, whatever I was showing, is over now. My 40-minute session is almost over. You can shoot out any question right now. 2 minutes are there. I'll wait till the end of the automatic end of this thing, and after that we'll restart after about 5 minutes. So anyone wants to ask anything can unmute and ask. Anyone? Any doubt? We still have the last session. If people have doubts and if there's sufficient people, you can ask and we can have discussions. I'm seeing some message in chat. Okay, there's nothing. Okay. I'm exiting this slideshow. I'm also stopping screen sharing so that you can see the whole view. Now, next session, I'll directly go in the QGIS software and we will actually, whatever map screenshot I showed, we will actually create that map, try to create it. I'm going to go slowly. If we finish it within 40 minutes, well and good. If we don't finish, we'll continue on next Sunday. So now this session will end and I am going to restart the session after about 5 minutes because the minimum time that is required for saving the video. After the recording of the video, it takes about 5 minutes to save. So that much time I'll take. So I'm ending the meeting. That is happens. Okay, there are already 5 participants. So I'll go immediately start the actual working, whatever. Now this is, sorry, I had not started the sharing screen. One moment. One moment. Share screen, yes. Okay, so I have started sharing screen. Now this is we are now in QGIS. I was taking that screenshot, so I have that previous map which I made. We are going to make this from scratch, but I'm just going to show you this attribute view was there. I am zooming the whole map. This is looking something with dots or a lot of dots. So now it looks more clean. We are going to do this slowly again. So this time I was just trying to show you how QGIS looks. Now I'm in QGIS. Now what I'm going to do is I'm going to start a new project. Now in QGIS or any GIS software, whenever you start the software, you are to make a map, you have to start mostly as a project. The name would mostly be project. It could be something different from in different software. So I'm going to start a new project. It's asking me whether I want to save the previous one. I say don't save. So this is what I get. The moment I start a new project, I get a clean window. There's nothing there. Now, what are the areas that I had shown earlier is this is the layers part, and there's a browser also here. Now we are going to use both layers and browser, and this is where you will see the actual map. So how do we actually get the layers, insert them? In detail, we are going to learn in subsequent sessions, but I've already made something easy here. What I've done is in my browser, which can show me data from my hard disk, I have added the folder, the folder containing the data to my favorites. So I can directly go and select data from here. So how do you start, or where do you start? For this presentation and for even your own use, it would be best to start with a blank map with latitude, longitude only shown. So what I go to is, see, these are the layers that I have, or geodata layers that I have. Coastline is there, countries are there, then graticule, populated places, state some trace this thing, world. Somebody's voice is not muted. That's why noise is coming probably. So please mute yourself. The first thing that I'm going to go is graticule. This is called as graticule in GIS terminology. It's basically nothing but latitude, longitude. So I'm going to drag this shape, whatever is called as, and put it in the map. You can drag and drop it in the map, or you can drag and drop it in layers. Right now, I'm not seeing the layers panel, so I'm dragging. So the moment I do that, I see these latitude, longitude grid. Okay. Now this is the latitude, longitude grid. And the way I told you earlier, this grid also will have attributes. I have not checked their attributes. So let me check, just try to, as a curiosity, try to check what it is. So this one line shows as degrees 15, direction east, displays 15 east. So this is latitude 15 east. So if I click on this, it shows latitude 120 west. These are just for checking what it is. Now, as I told you, this is what kind of layer. I earlier told you we have vector graphics as well as raster graphics. So this is a vector layer. So I'm going to go slowly. If you have doubts, you can ask. Now I have geodatas here, multiple geodatas here. I have picked up one geodata, which is a vector layer, and I have put it in this. Now, this is graticule, which is just lines. So it is type, its type is paths. So it has very multiple lines, horizontal and vertical. These are paths. And these are spaced 15 degrees apart, both latitude as well as longitude. So that's why this graticule is named as 15 here. You can see 15 here. Any 10M, you forget what it is. That we will go discuss. Any means natural earth. 10M means 10 meter for your information. Not 10 meter, sorry, 10 million. 15 is the 15-degree interval between the latitude, each graduation. That is the information that this geodata layer is showing. The next thing that we are going to put in is coastline. Meaning, before we go to the countries, we are going to insert the coastline data. So I just drag and drop this, and I can see this coastline. Looks like a simple map. So now what I'm doing is I'm going to the layers panel. Now I can see two layers here. Now I can see two layers here. I'm making it a little smaller. So one layer is 10-meter coastline, 10 million scale coastline. Otherwise, 10 million scale graticules, which are 15 degrees apart. And these are the two layers that I'm seeing. Now, what has happened is I have taken geodata, put it in QGIS map, and geodata has become a layer in my QGIS map. Each geodata set makes a different layer. Now, what I can do from here in this layers panel is I can put the layers off. See here. Now the latitude, longitude has disappeared because I have put it off. Now this coastline also has disappeared. So I can have any of the layers either put on or off, which is a simple operation. Now, since I have inserted it directly and I have not done any coloring or whatever, its color is already assigned by the QGIS software. I want some better color. So now this is something that will be discussed in detail later. But I have to do it now, so I'm just showing you. Now to change the color, what I go to is I click on that layer, right click it, go to the properties. In the properties, I have all this. Now within this, there's something called as symbology. So in symbology, I can change how it appears. So for clearer this thing, meaning for it to appear, make it clear, I'm going to change the color of this latitude, longitude to red. So it will be prominent. So I have just changed the color of the latitude, longitudes to red, and now they appear red. Okay. Now the coastline, I'm going to go there, and I'm going to do something similar. I'm going to change it from whatever color it has to blue. Don't concentrate on how I'm doing it, because that is going to be taught in detailing later. Right now, we'll concentrate only as a demonstration, how I'm doing it. Don't have to know how precisely you have to do it. You don't have to do it tomorrow. You don't have to yourself do anything tomorrow. You have to just watch and understand what I'm doing. So what I've done now is, so far, is I have inserted two geodata sets from readily available data sets in my map. One is latitude, longitude grid, and other is the coastal outlet. So far, so good. But this is a simple map which is rectangular. We want the map to look something different, meaning in the sense we have a spherical map or a oblong map or whatever, different types of map. So how do we do that? Now, once you have done this, what you can always do is zoom in and zoom out. So I have to show you that. You can zoom in and zoom out. Now I'm doing it using mouse. If you use the mouse wheel, it will zoom in and out. I can drag with the middle button to pan if it is required. This is called as a panning operation. To see the whole map in one go, this is the button that you have to press. You just press it and you see the whole button. Now let me zoom on India. So I have zoomed in on the India portion, and now I'm panning. So panning is used like this. So we can see now here you can see how detailed the coastline is. Let me show you some interesting coastline which I always like to show and enjoy. The coastline of Chile. Chile has a very intricate and interesting coastline with many islands. So this is the coastline of Chile that we are seeing. Similar way, we have our own, it may not be as shown in detail, as much detail here. Our own Bay of Bengal coastline near the islands, it's shown like this. It's very intricate, not as much. So this is the coastline that we are seeing. Now I want to show this map in a different shape. For that, what we do is we go to the project, choose properties. Once you see project properties, you see many of the things here. Here we have many properties like general. Then there are several settings. So what is important to us right now is what is CRS, which is the coordinate reference system, which I mentioned in the previous session. So CRS is the very important property that you'll often change for your map view. How you want, depending on how you choose the CRS, your map will look different. So there are many options here, meaning they have all gathered together the way I have used them. I choose one option called as world mole-wide. Mole-wide is a name. So most of these projections or coordinate reference systems are named. So as I told you, with a click of a button, I've changed the appearance. I told you earlier also. So now this is a mole-wide system or mole-wide coordinate reference system in which the map looks like this. Now, why do we need all these different types of systems? What are they used? We are going to cover in detail later. But the most important thing is a spherical map, which is on a spherical Earth, cannot be put in a plane map without distortion. First and most important rule. The Earth is spherical. You cannot make a flat map of it without some kind of distortion. Now, what are those distortions? We are going to in detail learn about them later, but I'll mention them now. The distortion is either in angle, or it is in the distance between the 2 points, or it is in area. Depending on what projection you use, we get different types of distortions, less or more, but distortion is always there. So we try to make different maps to eliminate one of the type of distortion depending on our purpose. Now in this map, mole-wide map, the area distortion has been reduced. Now you might have read on various social media and many places now blaming some of those projections. People say that Mercator maps are very bad. Mercator maps were you taught to us in school and we have unlearned so much and we have some wrong information. It's not like that. Every flat map is distorted. Some people are blaming only Mercator map. I'll show you what is Mercator. I hope that projection is in my list here. Wait a moment. Project properties, CRS, mole-wide. I can always search and use it. Okay. Pseudo Mercator is here. Let me use that. Okay. This is the Mercator projection. Meaning, I didn't want to search, so whatever was readily available, I used it. In Mercator projection, what is there and what you can see is the Greenland has become very large, very, very large. So I see many posts on social media saying that I have been wrongly informed in school, wrongly taught, this projection was wrong. And so I have now this projection, which is right. No, that is incorrect. No flat projection on a plane map can be 100% correct. Mercator projection has a lot of area distortion, but this had a purpose. Because in this projection, the directions are maintained correct. I mean, this was used for navigation by people who were traveling on the sea, high seas. So this is a different projection. Now I'll go back and change another projection to that India top projection, which I had. Space India, I called it. So now we see the projection which I had shown earlier with as if it is seen from space, and the India is at the center. Now here I see some distortion. This longitude, this latitude has come out, and then there's a straight line. Some of these things do happen when you reproject a map. Here also it has come straight line. You need to be careful about how the data is used or how the projection is set up and all that. So some of these some of these errors you can see, these kind of things are called as artifacts, meaning unnecessarily or wrong line or something drawn, which is called as an artifact. Okay, so now let me go back to the original projection, what I was showing, and we will insert one more layer. Anyone has any doubt can ask me. You can pause and ask also, or you can ask later in the next session. I'm going to back to my rectangular map. So here it is. So far we have 2 layers. Now let me go back to the browser and insert another layer. I'll insert the layer called as countries. Now here I have this, and I am inserting it here. Sorry. So I have got the countries. Now I'm making this layer slightly smaller again. Okay, so that you can see the whole map. So what we have got here? Now we have got 3 layers. Graticule, we have coastline, and we have country boundaries. Now what we see here is what has happened is the moment I inserted this country boundary layer, my graticule or the latitude longitude has disappeared behind those countries. Why it has gone away is because it is behind. So what you can do is in this layers panel, you can just pull these layers up and down. I have pulled it one level up. Graticule has come to the 2nd level, but still it is not showing. So I bring the graticule right on top. Now I can see the graticule, the latitude, longitude layers right on top above the countries. So you can order layers the way you want to let their appearance be correctly shown. Now the next thing what I want is all the countries are colored same. So what do? I want the countries to be colored differently. So that is where you go into symbology. I click on this country layer, right click, go to properties, go to symbology. Okay, now here I'm going to spend a little more time on symbology, though I'm not teaching you symbology now. Remember, I'm not teaching you symbology. I'm just demonstrating you how to make a map. Right on top, what you see is it says single symbol. So all the countries are colored same because I have chosen, or by default, it has chosen single symbol. So I don't want single symbol. So there are many options here, out of which I'll choose categorized. I want to make it into some categories because I don't want 174 countries to have all 174 color. I've just used a random number. The number of countries, I don't remember how much are there. We can check it. So I don't want them to have random numbers. So I'm choosing categorize. Now, now this is a very important feature of GIS, all GIS software. You can categorize them based on some information which is into those countries. So moment I choose and categorize, it asks me value. So categorize on what value? Now, if I click on this, it will show me the different attributes that that country layer has. It shows me the name, feature clearance, scale rank, this whatever. So if I choose scale rank, let me choose scale rank. And then I go to this symbols and I choose, instead of a simple fill, I choose I choose color ramp, random colors here. I'll choose some random colors. So we have got a color ramp of random colors. Now it is still showing that pink color there. So what I need to do is I have to say classify. So what it has done is I said scale rank. I use scale rank as a variable. Now, here, if you don't understand, you look at the video again. I'm still going slowly. The next time you go look at the video. I've chosen the scale rank as a variable on which these colors will be set. Now, then I've said classify. So, and I've chosen a color ramp. So from this color ramp or multiple colors, it has chosen the value of the symbol, which is classification of the countries based on 0, 1, 3, 5, 6, whatever. Now I can also add the, anyway, I'll keep it at those 1, 3, 5, 6 classes. I don't mind. And then I just say, okay. Something has gone wrong. Okay, probably the classification was didn't have much of different values. Let me check. Okay, all the countries have been classified under 0. So the classify thing didn't work because it is showing 0 here. So let me do change the property again, and let me change it to something that I really want. This was a random thing that I tried, which didn't work. So this happens. Now what I want to do is I want to use a property that is already available for coloring a map. You see here map color 7, map color 8, map color 9, map color 13. These properties have already been assigned to those countries in such a way that not two adjacent countries will have the same color. So I am choosing, let me choose map color 8. I choose map color 8 as the property, and now I do classify again. I reclassify again, and this black color I don't want. I have classified those countries. Let's see if it has had effect, or again we have fumbled. Okay, it has done something. So what I don't like from here is I don't like the black color. So I can go back on the properties, go back in the symbology, and I can individually change this black color. I double click on it, choose the simple fill, and choose a fill color which is something else. Okay, so that black color has changed to maroon red. I already have a red color. Let me change that red color to slightly dimmer. I'll make it slightly light. Okay. I think what colors we show here is not critically important. What we have ended up doing is we have colored all these countries differently now. Now we have achieved one simple map. Now we have a map with a grid of latitude, longitude, outline of seas, and different colors of different countries. Now, if we zoom on the map, we can see this. Now, I want this sea line to be prominent. So what I have to do is I have to bring the coastline above the countries. I brought the coastline above the countries. Now I am making the coastline as thicker. So the width was given here. I am purposely making it a bit more thick. See here. Now what happens is the coastline becomes very thick and clear. It's a bit too thick for the map. Let me reduce it. I'm making it 1.5. Okay. So what I have done is a map of countries with different colors and coastline, which is only blue. And I have my map. If this much is sufficient, you can take a screenshot, print out, or whatever, and you have your country map. Now let us explore this map. To see which is which country, what I can do is I can go into this I symbol, click on the country, and it will show me all the attribute information here. This is Sudan. I click here. I think this is North and South Sudan or something like that. I'm too bad at remembering countries, which my friends also know, who are some people who are attending. Now, this is Nigeria. Now this is Brazil, a large country. So we can see which is which country by clicking on this eye or information arrow and clicking on the country. But I want the country name to be seen here. So what I can do is I go back again in the country properties. Symbology was there. Similar way, there is what is called as labels. And the moment I click on labels, I see no labels here. By default, it is no label. So let me change from no label to a single label. And it is by default chosen value is name. Let me just say OK and see what happens. See here. So we have automatically got name of each country directly inserted on the country. But if I zoom, what happens? That name becomes smaller and smaller. So this is a specialty of GIS software. If somebody has used already CAD software or AutoCAD software or any other CAD software, then you'll know that this text is normally a standard color, a standard size. And if you keep zooming, then the text will get enlarged. Not in this case. In GIS, the text remains one size. You can change the size, of course. You can make it enlarged, but it will be almost that size or relative to the screen, whatever amount you zoom in. So now I have a map with country names also. So this is good enough as a starting point to make a print or take a screenshot and print it. I have made this map. It took me whatever, 15 minutes to make a map from a ready-made layer. And I can immediately change it to some other projection. Let us do it. Let's go to, sorry, not here. Not for, okay, here I have to repeat. The projection property is in the project properties, not in the layer properties. Let me change it to world model. I'll keep that same for some time. So the projection of the entire map is in your project properties. Appearance of each layer is in the layer properties. So right click on the layer, choose properties and change the appearance. So far, so good. I'll pause for a minute here. If anyone wants to ask anything, you can immediately ask. Whoever doesn't want to attend the last session for questions, you can ask. I might give a short answer. Anyone? Okay, I'll proceed. Now what we want to do is we want some more layers. The first most obvious layer internationally is the rivers layer. So I'm going back into the browser. Now I have my coastline, countries, gratitude, done, populated places, state boundary, trace. Trace is not required. I want world rivers. I drag and drop it here. So now I have the rivers also. I zoom to the full map. Again, every time you insert a new layer, you may have to change its symbology and its appearance depending on your need or whatever is your plan. So I'm going to symbology of the lever. Single symbol is okay, good enough for me. I'll change the color from red to blue. So I have the reverse looking blue now. Okay, so this looks like a good map without much details. But the next question is the sea still looks white. What do I do? For the sea, there could be many other options, or there could be a raster layer of sea, which is also available, meaning how the sea depth looks all shaded and all that. But that will make it too heavy. So instead of that, there's a very simple alternative. What we go is go into project properties, and in general properties, we set the background color itself to whatever we want. So let me make the sea as light blue. Okay. Now this is made the background itself as light blue. So you won't see any, see that color limited to the world map. It is showing everywhere. But when I zoom in like this, so that is good enough for me. If I'm taking a screenshot or making a printout of only this much map, this is good enough for me that sea looks light green, and countries are colored and rivers are blue and all that. So this is a good enough map. 10 minutes are left. So I'll just add one more layer, and further we will continue on next Sunday. What I'm going to do now is I'm going to add the layer of the Indian states. This layer is called a state boundary. So I'll add the state boundary layer by dragging and dropping it here. So I've got the state boundaries. Now I have this map. Now for this, the suitable projection would be centered on India. So let me do that. Project properties, CRS, space India. There we go. So what I now have is India country. The entire country is shown orange. I have no political intentions or affiliations as far as teaching is concerned. So it is done by QGIS and not by me. Anyway, so let us now change the colors of India also, meaning change the colors of different states. Go back to properties. Instead of single symbol, I'll say categorized. Same way again. Now here, the states have not been given any, the state values, the state attributes that I have, they don't have any categorization of colors as such. So I'm going to just use random colors. Random colors, I do spectral, and let me say classify what happens. So now each state has been colored differently, meaning all the states have, I could reduce the number, meaning I could reduce the class as by reducing it by minus whatever, but I'll leave it as it is. Let each state be colored differently. I have no objection. And I just say okay. So now I have India state, India with different colored states, and I have the map there. What has happened is rivers have gone below. So let me get the world rivers above the India boundary. Now the rivers are seen again. Now I'm interested in India, so I don't want the world to be colorful. So I'm again going back and changing the properties of the world layer. Here now, instead of this, I'm choosing grays. And I'll say okay. So far so good. So what now we have is a India map with states colored differently, and the world map in countries colored differently, but with gray shades, India with colored shades. And I have the rivers. I'm not going to put any more layer today because we just have 5 minutes left. After 5 minutes, this session will end. Whoever wants to discuss any doubts are welcome. Again, I'll start a session after 5 minutes or so. If nobody comes, I'll close it after waiting for 5 minutes. We can discuss doubts and they will also be recorded. And people viewing YouTube can see those discussion also. Now what I want is I want to see the names of the states. So I'll go back to, sorry, I choose the wrong layer. I go to state boundary. I choose properties. I choose labels. Instead of no labels, I'll say single labels. And value is state because there's no other attribute here, just the names of the states. And here I'll make the size of the text slightly larger. I'll make it 15. And I just say okay. So this is what I have. Since I made the value of the text height slightly higher, it is overlapping some state. But if I zoom in, it will be shown correctly. So I can see different states colored differently, which I can manipulate each color separately so that no adjacent colors are similar, I can do many of the things. So there we are. We have 4 minutes left, and I'm just zooming in the whole map, and this is it. So within 4 minutes, I could insert one more layer, but I don't think it's necessary. If anyone wants to ask a doubt, I'll stop the presentation now, or I'll stop the screen sharing. I'll not stop the screen sharing because I may need it. So you can shoot out, unmute yourself, ask anything. If I have a detailed answer, I'll give it in the session subsequent to this, after find out session. If I can quickly tell you, I can tell you now within 3 minutes. Anyone?
Yeah, Jitendra here, sir. Yeah. So one question, probably not related to this particular session.
Okay.
Just I wanted to know, using this software, can we calculate the length of the boundary of any country or any
Yes,
state?
yes. It will be displayed. It will be displayed. You can calculate, you can manipulate. Length of the country boundary or anything is or can also be an attribute. Meaning it could be part of the attribute which is shown as perimeter. Let us check. The country boundary might have perimeter. I don't remember all the things. Let me go to this country. If the perimeter is there, let me check. Or if not, you can calculate and add it. The software can add it as a perimeter in proper kilometers, independent of latitude, longitude, independent of projection. I don't see perimeter here. It could be there because there are too many attributes here. Sovereign country, this, that. You can do any calculation. You can actually do any kind of calculation area. You can do splitting. All that is processing, meaning you can get layers from the correct source which already have those parameters, or you can do it yourself using the software. No, the parameter is not here already as an attribute. But it can be added as an attribute or it can be calculated.
So my further question would be like, I had read one of your answer on Quora.
Okay.
So till what depth it go to calculate that perimeter? Because there are a lot of curvature would be there, especially in case of boundaries. So
okay.
Yeah, so that's my point where I'm going.
Yeah, that's a good question. Wait. If I zoom in here, let me zoom in. That coastline paradox is an interesting thing. Now what happens is, here the coastline paradox is not there. Coastline paradox is when you are actually measuring a real coastline on the earth. In the map, the coastline is already drawn.
Okay.
To a certain accuracy. So
I got
the moment it is already drawn to a certain accuracy, it will calculate the parameter geometrically of whatever you are seeing on the screen.
Okay.
Coastline paradox is gone. Now, if I calculate the coastline of the entire world here, here you can see that the coastline is more kind of say less accurate, and country boundaries are more accurate. So if you calculate the country boundary from using the world coastline, it will be lesser, and if you calculate the country boundary using the country boundary, it will be more.
Okay. So like as you shown in just, can you zoom it again? The same thing.
Okay.
So now we can see that there is a little inaccuracy over here. Okay. So
yes.
Is there a way to make it more accurate? I can change some parameters so that it will actually trace whatever is being seen on the screen. Okay. Okay.
Once the data source is there.
Hello.
So I'm back to that same view which was earlier there. Regarding the coastline or any accuracy of any feature, whatever data is already there that has a geometry, and any calculation will use that as a geometry. Whatever geometry is there, that will be used. Now, every data source will have different levels of accuracy depending on how it is made or what purpose it is made, what is the source and all that. Actually, natural earth data also comes with 3 levels of accuracies. We can, now that I'm showing this in doubt session, I can even go to natural earth. I need not go because it will be a distraction. Natural earth data comes in 3 different accuracies, which is 110 million, 10 million and 50 million scale. Now, data with lesser accuracy will always have smaller size. That's the advantage. As you go on increasing the accuracy, the data becomes very huge, especially when you are having the whole world data, it becomes cumbersome and difficult to handle. So every data set will have a set predetermined accuracy. Now you can do geoprocessing to make the data lighter, what is called as a generalization. The process is called generalization in GIS terminology, where you reduce the number of vertices. Now, basically, what is important here is, let me show you something else. This is countries layer, I guess. One moment. Yeah, that was countries layer. I go into toggle editing and I go into vertices. Now it is not. See here. Now you can see how many vertices it has. This is very easy to know. So these are all the vertices. And in GIS, the line between the vertices is always a straight line. So it has all these many vertices. Now, when I do generalization of a heavy data set, I can reduce the number of vertices by following some rules and make it lighter and make it maybe a little smoother or whatever. But it cannot be increased. The accuracy of a data set cannot be increased by any process. So that is the basic principle. I think you got your answer. And the perimeter or anything, whatever needs to be calculated, will be calculated on based on whatever is shown as the current geometry or whatever is the data available. Anything else?
No, sir, all good. Thank you.
Yeah. Anyone else is there? I don't know how many people are there. Let me check.
Apart from Amrish Damle is there.
Okay. Ambarish? ऐकू येतंय?
येते.
हा, कसं वाटलं?
छान.
छान, गुड. तू कितवीला आहेस? 6वी म्हणाली नाही?
7वी.
7वी, ग्रेट. अजून कोणाला इंटरेस्ट असेल, कोणाला भाग घ्यायचा असेल तर सांग, म्हणजे मुलं असली तर चांगले.
ओके.
ओके, बाय.
बाय.
Okay, sir. Thank you. Thank you very much.
You will have the videos. I'll send the link. Okay.
Sure. Thank you.
I'll stop here.
Yeah. Thank you.
Bye.
Bye-bye.
Bye.